So let's have a look at the assessment. Okay, I'm not going to go through every part of the assessment today because it's too big. What we're going to do is we're going to look at a few of it, and next week we're going to look at a little bit more and so forth. And hopefully, as we're covering the topics, I'll hopefully be hinting, hey, yeah, hint, this might be part of the assignment. So you can see that it's a big one. It's the main one. It's the biggest one of the 3 assessments. But it starts off. Let's actually look at the support files first of all. I might just close the door. So with the support files, here they are. It's a zip file, and if we show in folder, did I do show in folder? Yes, I did. Here it is. I think I've already downloaded it previously, but all you have to do is right click and extract all, and then it gets extracted. Okay, so the first thing I want to talk about is the organizational requirements. You can see there's a whole heap of information, and they'll be used as we go along in the project. But this organizational requirements effectively is a project tender. Okay, if you've ever if you worked on any projects or anything like that, been part of a project, what happens is that these companies who need these works to be done advertise these projects to be tendered, especially the larger ones. And then companies who are in this industry actually bid on the projects in the sense that they'll put a design together, quote the price, and all those kind of things, and then deliver a project. Okay, so this is a request for tender. And just to give you a bit of a background, this company is called TSA Meats, and there's a sort of organizational structure, but that's not too important. But the background is that TSA Meats is a family-owned business that's been established since 1982, producing high-quality meat products. So think of a butcher, think of a place that you can get meat, wholesale meat. So they're sourced from local farmers and their ethical practice. So that's that. Here's a bit of the office plan. You can see there's a server room, and then there's offices, and these computers are all connected to the server room. So, but the scenario. So, like we've been saying in other subjects, all your TFSA assessments are sort of like scenario based, as if you're doing the job, as if you're working. So that when you finish, you're not going to be totally unfamiliar with dealing with clients, dealing with expectations, and working in a team and a project. So you are employed by IT Works. That's our TFSA fictional company for IT students. It is an ICT consulting business in Adelaide. That's an American spelling. That's why it's coming up. All right, go away. IT Work has been contracted to design and implement a small network for a local business that specializes in small goods produce called TSA Meats. TSA Meats requires an upgrade to the network infrastructure. Staff are complaining when uploading large, high-quality pictures of their products. They are experiencing the following issues. They must take the picture on the factory floor. They must then take the device back to the office, and then they must upload images. If you think about it, there's a factory floor. They're making them products. Part of their process is to periodically do quality checks by taking a meat and assessing the quality and uploading to their quality assurance system. Okay, but if they're on the factory floor, walking around with their device, could be a mobile phone, could be a camera, could be whatever. But then if they can't upload it at that point, they have to walk, let's say, the 250 meters that it needs to go back to the office and upload it. That's a lot of walking unnecessarily. Okay, so that's one of the problems. When uploading these images in bulk, so because they've taken so many images because of their quality assurance, let's say 150 images, the progress is very slow. So these are large, high quality images, and the upload is slow. It is suspected that the network infrastructure is slow and unreliable. So that's a hint. It's slow and unreliable. So you can obviously there's no real network for you to investigate, but you can take that as a bit of a hint as to where the problem is going. There's a dude called Joe Bloggs. He's the finance minister, and pretty much everything goes through him, and everything gets approved by him. So there's a current staffing is 22 staff, 13 of whom work on the factory floor. Obviously, most of your team is on the factory floor producing the products. You have been allocated a $25,000 budget for the entire project. The finance manager is very strict on the project overruns and believes that it's a sufficient budget. So obviously, if we gave you an unlimited budget, you could just go crazy and buy the best of everything. That's not the point, is it? The point is getting the right solution for the right size company for their requirements. It's not just to go buy the very best of everything and then that's your solution for everyone, because that's not in the budget of everyone. So if we look at this representation right now, this is the address. This is going to become pertinent in the future. So just what's to keep that in mind. But right now, basically, they have the office admin people. They've got a switch. If you don't know what a switch is, think of these things with all these ports. And basically, if you think of these computers as office computers, they all plug into the wall. They come through the wall, comes out of these patch panels, and they're attached into the switches to put them on the same network. Okay, that's what a basic function of the switch is, to put them on the same physical network. And that's fine. They have a server. This is the server, the web server, the DNS server. This is the server where your images are uploaded to. Okay, all those high quality images. Then they've got a ADSL router, which connects them to their ISP. Okay, pretty simple. Apart from the server, it's probably almost exactly the same as what you got at home. And the switch and the router is probably the same device at home, but it's basically doing the same purpose. So this is the switch. It's a 100 megabits. It's end of life. That's a key word, isn't it? End of life, meaning that it should be replaced. Okay, it's 100 megabits per second. Is that the current speeds that you should be expecting in a local area network? No, what's the speed that you would expect if you were on a local area network? Just a normal speed. You buy a computer, you plug into the network. What speed are you thinking of? 1 gigabit. Okay, so if you look at all of these computers in front of us, if we go to the device manager, all right, the minimum these days on a LAN on every computer is pretty much a gigabit controller, a gigabit network interface card. So if you don't know what this is saying, this is a Realtek PCI Express gigabit Ethernet family controller. Okay, so if I bring up my, it's the wrong one. If I bring up my interfaces on this computer in front of us, this is just like any example of computers. And if we go to this traditional view, so this is the Ethernet adapter. You can see that's the PCI Express gigabit. And if we open this up, you can see that the speed is 1 gigabit. Okay, that's effectively 1024 megabits per second, which is if we're going back to our thing, about 10 times more faster than this. Okay, you can see that that's at the end of life. It doesn't matter all your computers are capable of gigabit. If this device, which is at the center of it, is only 100 megabit, these computers will only be able to work at 100 megabits per second. So it's a sort of bottleneck if you want to think about it. It's a slow point. It's like if you're going to the city, it's like it's Anzac Highway. Okay, you've got so many cars on the Anzac Highway coming to the city this morning, and no one's going to be going very fast. All right, here's the exact model. Okay, it's a 24 port. It's 10100, meaning it can work at 10 megabits or 100 megabit. It's fast Ethernet. It's unmanaged, meaning it's not very smart. Just connects devices together. There's 2 uplink ports. Ooh, if you're wondering what uplink ports are, these are special ports which are connected to the backbone. So if you look at these are 2 extra ports, aren't they? They're usually faster. Okay. they're connected to a backbone. The backbone is usually a higher speed network. Just think about it. If we all got these little streets in the suburbs, but obviously it connects to those major roads so you can get to places faster, right? They're like the backbone of your city. And those backbone uplinks are meant to connect to the rest of your network so that it can actually be like those highways between little towns or between little suburbs, okay? So, but it's got two uplink bays of copper or fiber, so we can switch out copper or fiber things, so it's removable. You can, this picture doesn't do it justice, but let's see if we can zoom in a little bit. See, you see this? You see those little silver things? You can actually unscrew them and take them out. And same with these ones. And basically we can then change the type of module it is based on what we need, whether that's fiber or copper, so we can be flexible. And obviously if you don't know what I mean by fiber or copper effectively are these cables. Okay? There's copper metal inside, and it's very cheap, very easy to use, etc., etc. It has its downsides as well because it's susceptible to interference. But the fiber, if you've never heard of that, is actually made from glass fibers internally, and they use light rather than electrical impulses, and they usually can go over longer distances and are not as susceptible to magnetic interference. That's interesting. But they're only gigabit anyway, so even those are just the normal speed. The ADSL wireless SOHO router. SOHO means small office, home office, so it's not really something for a business, really, a big or medium big business. It's only really for small business. It's only for internet connectivity only, so it's not for wireless access for the users here. They've got an ADSL internet connection. So when we say ADSL, we're talking about pre-broadband, pre-NBN. We're talking about the 1.5 megabits per second up to 25 megabits per second if you're right next to the exchange. So not very fast. The server is a server 2019. You can look at this. It's got 16 gigs of RAM, solid state hard drive. So let's just rule out the fact that the server is at all a problem. Okay, so if you didn't hear me just then, there is no problem with the server or any of the computers. All right, don't concentrate your solution on replacing the server or replacing the desktop computers. That's not the project. The project is to replace the network infrastructure, like the switch, like the internet connection, like the cabling. That's what this subject's all about, okay? In the future, you'll be doing a server subject, and maybe in that assignment, you need to concentrate on the servers and the services instead of the cabling and the connectivity. But this subject is all about connectivity. Here's an example of the website where they log in and they upload the photos. If you notice that just this part, I can't highlight that, just that part, but it says HTTPS, doesn't it? Okay, so what does that mean? Have you heard of something else that's similar but not the same? Okay, any examples of anything that's like that but it's different? So if I go and open up let's go to where I think oh no, that's secure as well. Okay, so let's get back to here. Let's just make sure. So what this is, HTTP is Hypertext Transport Protocol. It's for websites. It works on port 80. If you heard of that term, ports, okay? And we'll talk about this in the future. But this HTTPS is a secure form of that HTTP. S stands for security, it's encrypted, and it works on port 443. Why am I talking about all this? Because it becomes pertinent in the future, okay? Because we'll be learning about the addressing, IP addressing, port addressing, MAC addresses, and where do we use what. Okay, so if we look at this, it talks about the cables and the Cat5e as being the cable, and this is where we upload the photos. Again, the workstation. Again, if you have any ideas of it not being suitable, don't, because it's fine. Okay, nothing to do with the server, the workstation. They're all fine. You don't need to touch them. This is a new design. So your company, there's a network architect. This person has designed this as a solution. So you're not here to design the solution. You've been given a design. Okay, you're going to have a switch, you're going to have a router, and instead of just having the office administration area connected to this network, you're also going to have the factory floor. And this factory floor PC, it represents all the PCs that's on the factory floor. And then you're going to have effectively one network here. That's your office administration network. You've got the factory floor network, and you've got the internet. 3 legs. Okay, each one of these interfaces off a router is a different network. If they're a different network, what did I say last week? What do they need to be able to go from one network to another network? Sorry? A router. That's what that thing is. Yeah. And what is the device called on the network? Sorry? Switch. No, the switch is the connectivity device. What? Sorry? Gateway. Gateway, correct. All right, the router is referred to as the gateway. So if I was a router, if you remember me doing this, I've got my inside, I've got my other network. So as the router, I take traffic from here, I follow the rules, that's the routing protocols, and I determine where to send the traffic. In this case, it's got 3 arms. I've only got 2 to demonstrate, but if it's got 3, then you can choose between the 3 networks. So for each of these computers, this router's interface facing them becomes the gateway, the IP address of that. And we'll learn more about this. This is what is being chosen for the router. Okay, you don't have to go out and find that router. Okay, it's been given to you. It's got 3 gigabit Ethernet, so 1, 2, 3 for the 3 networks. Easy, okay? But it's got this license and all that kind of stuff. If you can look it up if you want, but no big deal. The internet access is currently ADSL, but they need you to get an NBN connection. I'm sure every one of you in here understands what that means. When you go get a new internet connection, there's things to consider: how much it costs, what's the download speed, what's the upload speed, and if you get a static IP address or not for business. A static IP address means that you have an IP address, the same one all the time. If you have a same IP address all the time, it means you can put something facing the internet, like a web server or any services, and be able to be reachable from people on the internet. Okay? So what is the requirements? The requirements is that it needs at least 60 megabits per second download and 20 megabits per second upload, and it must be it must be unlimited downloads, data downloads or uploads, and the preferred supplier is Telstra. I'm sure all of you guys are going to go, what? Why would you want to do Telstra? Well, it doesn't matter. This is the thing. A lot of companies have their preferred suppliers. If you haven't noticed, all of our computers in this TAFE campus are Lenovo. Okay, why? Because they've got the contract to supply TAFE and other government departments, so they're our preferred suppliers. So can we go out and buy a Dell computer? Not really. We'd be breaking our rules, okay? And we'll be breaking our contract. So if the company says their preferred supplier is Telstra, they argue, just use Telstra. Don't give your own comments, just use Telstra, okay? And the cost is $150 per month, and you need 1 static IP address. Okay, couple of things. Not too difficult. So it goes on, but right now we don't want to look too deeply into the rest right now, but let's just have a look at the first couple of questions. So review that requirement. So you know how I said there's all those extra supporting documents? So wherever there's a requirement for a supporting document, let me just open that on a desktop app. Maybe I should just save a copy locally, just in case I'm modifying something else. Let's put it in downloads. Yep. All right, so if we scroll through, if it says refer to this document, it means go look at the document, okay? So you don't need to look at every document straight away. Go through this, look at each question. Don't think of it as too big. Like someone says, how do you eat an elephant? One bite at a time, okay? This whole project is a big giant elephant. You can't do it all at once in one go. Do it a little bit at a time. Break it up. Okay, task 1 is the biggest one. So have a look at this thing. We just had a look at that. Determine what network hardware is still required to implement the network architect's design. So if we said that this is the design and this is the switch that, this is the router that's here, what do we need still? So we've got the servers, we've got the computers, that's all good. What other devices do we still need? Yeah, this is the router. They've already told you. This is what we're using, okay? So that's fine. We've got this. What else do we need? Switch. We need the switch. Yes, that's the one where you're probably going to have a lot of thinking about what you need. What else? Look at this diagram. What else do you need? If you've got the servers, sorry? No, you've got the servers. You've got the workstation. Remember I said nothing, sorry? No. Yes. So this internet connection, NBM router modem, okay? So those are the two main things you got left to get. All right, so let's keep on going. So what about the switch selection? So remember we just talked about the switch just then. That's something you need. So here's some requirements of what the switch is required to have. So what does that mean? This means that when you go look for a switch, and this is where you'll probably have to spend a little time researching, it has to be a Cisco switch, first of all. Second of all, it must. So in the future, we've got plans to introduce that 802.11ax Wi-Fi 6 access point. So this one, powering of APs. AP stands for access points. If you don't know what this is, I can put it down for you. PoE, okay? Power over Ethernet. What does this mean? See that device up there, right there, above, what's your name again? So above Faith's head, right there, there's a Aruba access point. So you see how it's right in the middle of the ceiling, right? You can see there's a light on. Do you think there's a power point right behind it? No. What happens is that these access points are connected to a cable just like this. It's running through a roof, back down, something like this, and plugged into a switch. But how does it get its power? The switch, the port that it's plugged into, is also capable of powering that device. And that's what's called power over Ethernet. And that's what I'm trying to tell you here. Okay? So that's a feature. Okay, not all switches have it. That's a feature that this switch must have. So these are all the features it must have. Speed of the wireless network. The switch must not be the bottleneck for the wireless access point. So if these are capable of 1 gigabit, so therefore the ports that these access points must plug into must be capable of more than 1 gigabit, if you like to think of it. So this is the access point that we want to plug in the future. Again, it gives you the exact model. And these are the speeds of the ports that it's capable of. So you could be 100 megabits per second, 1 gigabit, or 2.5 gigabits. You can see that gets even faster than normal LAN speeds, isn't it? So therefore, the access point, the port that it's plugged into, must be faster than the 1 gigabit. Okay, so for these backbone ports that we talked about just before, they can be at a higher speed. Okay, so the management console, all that kind of things is fine. So here it says power over if it wasn't obvious. if it wasn't obvious back here, okay? Cisco is the preferred manufacturer, and it's also needs to be capable of VLANs and quality of service. So if you don't know, if you never heard of that, that's QoS, quality of service. That's where they can prioritize some communications over other ones. And obviously the licensing must be approved by the finance manager. Okay, so there's a couple of things we had to select. So answer to this question, I think we almost worked it out just before, didn't we? Based on the existing devices, PC servers, and selected router, determine the maximum speed for each of the switch access ports. So if you remember, we looked at we had the hardware specifications of the switch and the the PCs and so forth. So where is it? Current workstation. Oh yeah, here it is. It's just gone onto the different page. Okay, it's saying it's 1 gigabit for the workstation. Oh, it's also, how convenient. It's also 1 gigabit for the server. So if they are capable only of 1 gigabit, what do you think? So they're going to all be plugged into these ports. If those computers have 1 gigabit network cards, what do you think these ports should be? Exactly right. It has to match up. There's no point there those being 10 gigabit because your devices only have 1 gigabit. Okay? Easy. That has to be, yeah, 1 gigabit. And again, it's talking about the router. If we look back at the router that we selected, it's got 3 gigabit Ethernet. Again, 1 gigabit, isn't it? So again, it's almost like leading you to the answer. All right, let's go free. You've reviewed the switch selection. So when we're selecting the new switch, we had those requirements. List free. Can we think of any free that we just mentioned? Features that the switch has? Name some. What do we just talk about? What is some of the features it must have? What do we say about that? And power over Ethernet. What else?
Quality of service.
Quality of service. What else? But I'm sure you can think of a few more. So I'm not going to do the whole thing for you, but that's what we're talking about. Okay, listing 3 things. So when we just have the acronyms like that, it's a little bit hard. Maybe have the acronyms plus a description of what it means. Okay. If we look at the internet access organizational requirements, determine the minimum performance speed. I'm sure you can just get that information straight out of the requirements, couldn't you? And then now on the number 5 is going to do some research and finding the internet connection. So if I was a student, what would I do? I would possibly, I know I'm not trying to be funny, but it's literally the preferred supplier is Telstra. NBM internet, and then we go to business internet, NBM plans, and then we $150, wasn't it? I guess that's let's see if we can find it. Remember what we said, that the address becomes important. You know, with the NBN, the NBN, we have to see if the address has NBN capability. Let's plug it in. There it is. I know, don't try to go to this address in real life. This does not, it's not a real business. It's not there. So now we've got, oh yes, you can get fiber to the premise. Oh my God, that's pretty good, isn't it? I'm not sure if you know all the differences, but you will by the end of this assignment. Fiber to premise, fiber to the curb, fiber to the node, fiber to the what's that one? To the building. What's the difference? You'll definitely know. All right, choose the plan. Let's go choose the plan. $100 per month for 3 months, then 110 afterwards. What's the speed? 50 megabits per second? Oh, that's not quite right, is it? What's the minimum requirement for downloads? If we go back to requirements, 60, correct. So we need to make sure that we choose the plan that meets the minimum, if not more. So that's not right. So maybe let's have a look at this other one. $100 per month for the first 3, then 140. Oh, just within budget. Oh, lucky. What do we get? 100 megabits per second, 32. Does that meet the requirements? Yeah. And what about the other thing? We had static IP address, wasn't it? If we keep on reading, and it's even got even better things. It's got backup 4G mobile network. Right. No worries, Gollum. I was hoping you'll be in class. But I'm sure you can take it from there. Finding an internet ISP plan is not something that you have not done. So we've already looked at, like I said, I don't want to go through the whole thing, but like I said, remember we talked about fiber to the premise, fiber to the node, fiber to the curb. What are they? I think just a bit of research can get that for you. The key thing is it's approximately 20 words, so don't try to write too much. Just tell me what it is, what's the difference, because obviously just telling me fiber to the node, FTTN is fiber to the node, that doesn't tell me much, okay? You probably have to talk about the speeds as a minimum. That's the most important thing about internet connection, isn't it? Is the speeds. Compare the speeds between the three and how it connects to your premise. All right, from the previous question, located here, insert a screenshot of the type of interconnect. So basically what do? I go to my thing, select this one, take a screenshot, put it in the question. Okay, so far so easy, guys. So far, okay, no worries. And then we need to look for a modem router. Okay, so if you look at the question says the default router modem that you get with Telstra, it's not the best. So what do we need to do? What you need to do is look for an alternative router, NBN router, that you can purchase for this company that's reliable, number one. They don't want to have to restart it all the time. I'm sure you've done that at home. You've had to restart your router because something's not working properly. So we might just leave it there for today. So like I said, we can't eat the whole elephant in one go. But I think if we look at what we've talked about just then, it's all doable, isn't it? It's all doable. And if you obviously it's been recorded. If you missed it, or people just joining online, then maybe watch the video afterwards. But like I said, you can't eat the elephant in one go. So how about you get started between now and next lesson to try to do some of these questions we just talked about. And next week we'll talk about a few more questions, and then we'll try to eat the elephant slowly over the next couple of weeks. And we've covered a few more now since last time we spoke about this. So let's go through another couple of questions, and hopefully those questions now make a lot more sense. So we went through 9. Sorry, let's go through 10. So 10 is all about the different types of physical cables. Okay, so if you remember a couple of weeks ago, we looked at different cables, and if you look at this, we've got UTP. If you're not sure about that, that's unshielded twisted pair. There's fiber single mode, where there's only one beam of laser, so only one stream of communication. There's fiber multi-mode, which is fiber optics, but you can send lots of beams in different phases or bouncing different way, so you can have multi streams of communication. So obviously, if you can only have one here, you can have two there. You're double the speed or amount of throughput. Then we have 802.11ax, and if you've never heard of that, you should have, because in question 9 was all about the new Wi-Fi standard AX, and that's what we're going to talk about today in our class. Not AX, but Wi-Fi in general. But then you've got these standards. Okay, Cat6a, so that's a specific type of unshielded twisted pair. There's OS2, so S stands for single, optical single, okay, standard 2. and this one is OM, the optical multi. Free. These are the different standards. So if I want to find out the connector type, the distance, expected maximum data speed, let's actually just get this out and put it in our browser. I'm not giving you an answer, I'm just saying what I would do. So forget about this little part. Max speed, or actually let's just see if we can get all of it in properties. Okay, so if I look at this, allows for extreme high data transmission rate up to 10 gigabits per second. And then let's have a quick look at what comes out. And then if we want to, obviously I could spend some, right? It doesn't have the distance here, maximum distance, but we got one bit of the question out, haven't we? Yeah, we got a bit of the thing. The distance is pretty easy. All twisted pair is 100 meters, isn't it? And the connector type, all twisted pair, is the RJ45. And the characteristics of this media is it's copper, and it's actually susceptible to interference, like we talked about during the lesson, to electromagnetic interference. That's around the place. All right, so this one's pretty easy. The up next two, it's a little bit less because we deal with it less, but same idea. Those two, just in case it thinks it's something else. Just in case it thinks it's that old operating system, OS2. But let's actually, oops, can't spell. All right, let's have a look at this. So if we quickly look at, oh, maybe that's specifications. Let's have a look at that. So typical attenuation, gigabit speeds, but it can have at, it's not giving us all of it. Let's have a look at this one maybe. Okay, this is a paper. Oh, look, there's a table here. Okay, so we can even see that this is talking about the OM free, and we can look at OM free. So which one was it for ours? Two, wasn't it? Two. Okay, let's look up OM2. That's the. I know we started off.
It's OM3.
Yeah. OS2. OM3 is it? So I know we started off looking at OS2, but you can see we can got some other information here as well. And look at that. That's come on in, take a seat. So what I'm trying to say is this is not when you're given standards like this, there's always going to be new standards. That's the whole nature of IT. The whole nature of IT is that you're going to get different stuff, different standards. Wi-Fi 6 is the latest Wi-Fi, but what I can do is just what you can do is just like what I've done there. Is just go research these standards, and you probably can get these things out of it. Okay, you find a good website, and I haven't found quite the good website yet, but just in my example, but you definitely can go down a little bit more and look at some of these websites. And look at this, we can even look at the, there was a picture, OS2, it's for outdoor up to, there's something, isn't it? Up to 200 kilometers. Hi, what was your name? Oh, John, I haven't seen you so long. You know why? You look, yeah, I haven't seen you so long. You look totally different from me. Okay, sorry about that, guys. I just noticed someone funny in my class, but it's just Jai. He's been online for a bit. I've sort of forgotten his face a little bit. No worries. That's okay. And that's why we have these online classes, not for everyone to be able to attend all the time. That's not what it's meant for, but just in case you're caught out, you can. Okay, so what am I trying to say? This table is just a matter of research. Okay, look up the standards, get these bits of information out of it. I don't think anyone's gonna be too concerned. But if you out of this information, right? So the characteristic, remember one of them was said outdoor, didn't it? If we had a look at this, we got the OS2 is for outdoor. What was the OSM? OM3, wasn't it? Yeah, OEM free. Oh, here we go. Multi-mode types. Let's have a look at this. OEM free, laser optimization, limitations, distance limitations. Oh, it's getting all of the information. Oh, a lot of the information we want to see. But if we look at this, this is in feet, and we probably should be. Look at this. We can even see the maximum speed here. 100 gigabits, gigabase. Yeah, gigabits per second. Yeah, so we can get that. So 330 foot. 330 foot. I don't know what feet is. Measurement converter. I know that's the problem with a lot of things being American, is that foot, 330 into meters is about 100 meters. Okay, and if we look at that, where was it? There's free. It's 300 meters. It's got meters here. Anyway, sorry, I missed that. It's got both. It's got meters, and but the maximum is almost like at the lowest rate. It's 300 meters. So now let's look at this. Which type of connection would you use for these type of things? So fiber, like I mentioned, is probably good for the backbone, for areas where there's a lot of interference. Remember when we talked about the cables, fiber is not susceptible to electromagnetic interference. And if we look at, remember this scenario, the scenario is this factory, isn't it? The factory's got machinery, it's got big electromagnetic motors. I think that's big clues, isn't it? So, and if you think, remember, there was an area here, new warehouse building, 500 meters outdoor. I'm not trying to be smart here, but obviously we just read a whole heap of specs just then, didn't we? So let's just talk about that one thing. Out of these things, 500 meters is already going to be too far for the OEM free, isn't it? And the other thing is it's too far for Wi-Fi, definitely. It's too far for the UTP, definitely. But which one is it suitable for? And which one said was outdoor? We just looked at. Okay, so any guesses?
The fiber from my fiber.
Yeah, the OS2, if you remember. Okay, so if we go back just to prove that I wasn't lying, I think OS2, somewhere it said outdoor. I don't know, somewhere. OS2, outdoor. Yeah, carry single mode, traverses. Yeah, I think this is too much information. But it's somewhere it says outdoor. Okay, so if you remember that. And also it's, I think it was up to how many kilometers as well, the distance? 200 kilometers. So that's more than sufficient for this purposes. But if we look at each one of these things, desktop computer, not moving around. So probably not fiber, probably no need for the Wi-Fi. The factory PC, which is surrounded by heavy machinery, so they should give you a clue, shouldn't it? Finance manager's iPad. Well, iPad, what can you stick into an iPad? Nothing really. All right, so it should give you some clues there. So I'm not going to totally give away the game, but I'm sure you can work it out yourself. It's not going to take much more. After you do the basic research, it's not going to take much more to put the right one for the right situation. Now, look, if we look at this other table, the good thing about having a table is that you don't have to have large answers. You just have to fill in the area that's missing. So if we talk about Office 365, the protocol, the software products, we're going to use it for. So this is Microsoft Office 365. Okay, it's not just it's not any other Office. It's Office 365. So I'll just give you an example. So I'm accessing Outlook 365. What protocol am I using? Sorry? Who said that? Randolph, was it? Which would you say? What did you say? HTTPS, exactly. That's what this part stands for. It's Hypertext Transfer Protocol Secure. Secure meaning it's encrypted. So again, this table, I'm sure you don't need to be a genius to work out how would I access that, right? I just show you. And again, if I want to go to my OneDrive, here's my OneDrive. What's the protocol? Okay. So we're not talking about your, any other type of sharing. Just one Office 365, OneDrive, Outlook, the websites. Okay. So again, what programs do you use to access these things? So web, I won't even need to tell you because there's a normal web and secure web. What are the protocols? Hey there, Matt. Remote terminal. This is an interesting one. Remote terminal. Have you heard me use the term remote terminal before? In what situation have you heard me use remote terminal? If you remember, when we were talking about these switches, routers, and whatever, if you remember, part of the basic configuration was to allow for remote administration. So we use something like the thing says, PuTTY. The PuTTY app to connect to the routers and switches so we can remotely administer it. Do you remember that? So here's the PuTTY app, and hopefully you'll realize that PuTTY for remote administration, so these the serial is like your console cable, if you remember me talking about that, but the telnet and the SSH are the two remote versions. The difference between the two, they're both remote command line interfaces, but the difference between the two is that telnet is clear text, meaning anyone can read anything you send, and SSH is a secure shell. As the name suggests, secure means it's encrypted. But if you even look at this, if I click on telnet, it says port 23. If I click on SSH, it's port 22. And let me just show you a thing called well-known ports. So well-known ports are basically the port numbers that's reserved for special functions. If I go here and I go to port 23, you can see that's for the telnet protocol. If I go to port 22, you can see that's for the secure shell protocol. Again, it's pretty much answers itself, doesn't it? All right, the next one is Windows file sharing. Oh, that's interesting. What do I do? We haven't learned about this in this subject, but obviously when you do this Microsoft Server one, you'll definitely learn about it. And look at this, it even tells me server message block, SMB. Okay, or sometimes it's also known as CIFS, a Common Internet File System. So again, plug in and I'll get the answers. And the video and voice communication, MS Teams. This is a little bit trickier, I've got to say. All right, so let's see, Teams uses multi, yeah, that's a little bit more difficult. But if we scroll down a little bit, what is best for voice? And it's going to talk about UDP versus TCP, and that's something we're going to talk about in the next lesson. Okay. So if we keep on going with this, so number 12, if we look at the organizational requirements, the network architect has already selected the router. The router is this one, so you don't have to worry about it. But there's a PDF and there's a pay as you grow. What does that mean? So if we go to our support files, we've got the Cisco 4000 data sheet here. So it's supplied to you. You just open it, go for find, pay as you grow. Not grown, pay as you grow. Here it is. Performance upgrade models, investment protection, capex budget. What does that all mean? So router capacity can increase with a remote performance on demand license upgrade for exceptional savings. So if you don't know exactly what that means, it means you buy this router. It's capable of this much, but if you actually go buy a router that's capable of this much capacity, you're going to spend a lot of money. But we always speak about scalability, and what Cisco has done is they're gonna, instead of they're trying to sell you a little router and a bigger router and another bigger router, you go out and buy all these things every time. Well, it's bad for them, because what if you change your mind, not go for Cisco next time you go and buy something? What they want to sell you is they want to sell you a bigger capacity router at a lower price. But they don't want you to just stick with that and then not making their money afterwards. They actually sell at a lower price, but when you buy at the lower price, they give you a certain license, and they're locked down. It's sort of locked down to a lower capacity or lower performance. But later on, you realize you need more performance. You just give them more money. They give you a better license, and you put that license on there, and suddenly you unlock more capacity. You see how it's advantageous to you in the sense you don't have to change that piece of equipment. You don't have to go out and buy another piece of equipment. You don't have to unplug it, reconfigure it, and do all those kind of things. You can see that you can just make it perform better by just paying more money. Okay, so I know that's money's money, but at the same time, Cisco is able to keep you as a customer and basically give you a discount on their products in the first place, but give you more performance by getting more money out of you through better subscription. Okay, a lot of things are like that. Even the Tesla, like I mentioned a couple of weeks ago, it's got autopilot, part of the software. You want to unlock it, you pay extra $30,000 or $10,000. I don't even know, but that's what it is. Pay as you grow. It literally means as you grow bigger, you pay more to unlock it. Okay, so based on that, in your own words, describe it. So now, based on that, on the table 4, what is the throughput? What is the default throughput? Sorry, what is throughput? What is the default throughput? So I think we talked about throughput before. Just look it up or find it in your, what is the default throughput in the data sheet. So table 4, where's table 4? That's table 1. If we go to table 4, here it is. So if we actually look at this, these are the different licenses, the default, the performance, and the boost license. And then you've got the different performance that you unlock for each of the license. I think that question pretty much answers itself if you find the answers in there. Okay. The last one is, do you recommend purchasing any of these additional licenses if the functionality is to just upload some photos? Yeah, it's a value. It's a lot of your judgment, isn't it? So if you remember, there's just 2 networks: the office admin network and the factory floor ad network, and the router sits in between. So the amount of traffic goes through the router between the 2 networks, and what they're doing is accessing the website, uploading these photos, and that's all they're doing. Okay, do you think they should spend extra money? It's not free. Extra money to increase the performance from these are the routers. I forgot which one it is, but let's which one was it? Which one was our router? It's a 4000 family, but it's specifically, let's look at the other one. It's a 4000 family, but you got to be specific, okay? So if you look at this, so don't get tricked by that. It's not 4000 is the family of routers, but the one that you've been selected is actually the 4331. You get me? 4331. 4000 is just the whole. It's like I've got the Toyota Camry, but there's the Camry SLE, Camry Performance Pack, Camry whatever. So there's different versions even in the same family. So if we look at the 4444331. Yeah, this one. That's the one. So we go down this list. Okay, so don't give me figures for this one or this one. It's this one. So we go from 100 megabits per second to 300 to 2 gigabits. Okay, and obviously there's a price to pay. For the functionality, you give me a value added judgment recommendation. Do we need to spend more money to go from here to here or to there? Okay, so there is, you have to always justify, okay? So what we'll do is we'll talk about, this is the new design. So if you look at it, there's it's just the old design, but breaking up the network into 2 networks now, the factory floor, which has got the heavy machinery and stuff like that, and the office admin area, which has got the server plus the computers. And we've got a switch here. Instead of the old switch, got a new switch, got the new router. And if you want to think about it, if you remember, every interface of a router connects to a different network. Remember that? And the router's job is to route between the networks to other networks and so forth. Okay, so the general rule is, not general rule, the rule is every interface of a router is a different network, and they should have a different subnet. So the IP address is a different IP address logical network as well as a physical network. All right, so if I want to go from factory floor PC to the web server, which are the intermediary devices? So if you remember, intermediary devices are devices that forwards your traffic from your computer to the destination. So which one are the intermediary devices? Router is definitely one. What's another one?
Switch.
Correct. Yeah, so these are 2. If you remember, what layer did I say the switch works at last week? Layer 2, correct. What layer is the router? Layer 3, correct. So if we look at this device, what's the PDU for the switch? Remember what's a PDU? Remember, a protocol data unit. Remember we have the different types of things we call it. When we go through a router, it's called a dis. When we go through a switch, it's called a dis. So for a switch, what was it? Frames. What was the router? Packets, correct. And what addressing information does switch use? Remember how I emphasized this is the important information for layer 2. What is the address that we use in layer 2? MAC address, correct. Incorrect. Okay, rest of you hopefully are getting it as well. You guys at the back, you okay? You're looking at me, listening? Yeah, all good? Lil Jack, you listen to me? You pay attention? All good? Okay. And for a router, what's the addressing information? IP address. Okay, we're going to cover that today. You online? All right. Okay, if you remember, we spoke about this last week as well. Remember I said, take a bit of note. What was the device memory location? So where you would store, how we said MAC addresses for the switch, right? Where do you store that information? MAC address table or the content addressable memory, if you remember, okay? Either both, doesn't matter. And what about for the router? Where does it store this addressing information? Ooh. I know we haven't covered it yet, but we sort of mentioned it a few times. All right, so we'll definitely cover it in the second lesson today. So let's keep on going. Just keep that in mind. Okay, so that's the reason why we're covering these questions. So either we've actually gone through the topic and we're sort of emphasizing it, or when we do go through the topic, you go, oh, I remember there was a question about this. Okay. Okay, so I think we'll stop there because the next part is really going to be covered in the next lesson's topic. Okay, so I won't go through all the stuff we've already covered, but let's start here. This is task 2, question 6. If you look at this, you can see that that's the OSI model on the left, and you've got the TCP/IP model in the next column. Then you got some blank columns where you have to fill in. Okay, so 2 protocols at each level. here, and a protocol here, and so forth. And obviously, if it's black, it means you don't have to do anything. And then a bit of characteristics of each of the layers. So just as a quick tip, where is it? Over here. If we actually go to our, let's have a look. Some of our previous topics. If we go to the protocol and models, remember the OSI model, the TCP/IP protocol. Yeah, we open up the PowerPoint. You notice that here, TCP and OSI models is exactly what we're talking about, isn't it? In that question, if we actually look at the learning resources, which is the PowerPoint or the chapter you're doing, but if we scroll down a few slides, dismiss, I think in all of these things, it talks about the bit of information around the place, but if we actually go find a specific slide, you pretty much have the OSI layers here. Sorry, the TCP/IP layers here. You've got various protocols here. Okay, so I'm sure you don't have to be a rocket scientist to work out maybe that's similar. Okay, with the characteristics, we're not looking at the specific protocols in here. We're looking at the characteristics of the application or the presentation session layer. Just a few words here. Same with the transport, the network, the data link, and the physical layer. I think we've been talking about these three already. In the future, we'll be talking about this one, and the upper layers we won't worry too much about. After the transport layer, pretty much it's a bit of a, as far as we need to know from Cisco point of view, we don't need to know too much about that, but I'm sure you can find a few bits of information out of that PowerPoint anyway. Okay, if we look at this diagram, okay, remember in the first lesson, I said we talked about broadcast, didn't we? How if a computer broadcasts and there's too many computers in the network and they all broadcast, they're going to make everyone slower because they're grabbing everyone's attention. So one of the reasons why we make a big network smaller is to actually contain these broadcasts to smaller and smaller amounts. Okay, and we can do this. We can do this by introducing routers. Okay, if you remember what I said, routers connect different networks together, didn't I? So if you remember what I said, if I ask you now, how many networks are in this diagram? Have a look. Call out your answers if you're ready. Three. Correct. Okay, because we said each interface is a different network. So you might say, oh, well, what about this one? The switch. The switch doesn't separate networks. They actually just connect the networks together. So if you look at how many interfaces, 1, 2, 3. That's why there's 3 networks. Okay, discuss and identify how the proposed network in figure 1, this is figure 1, has been segmented. So if you don't know what the word segmented is, it means divided. Okay, so what device is dividing it? What device is divided?
You need to explain everything?
No. Let's answer my question first, okay? Besides this, which device is separating it? The router. We just discussed that, didn't we? How is it separated? Well, the router is connecting the different networks together. Each interface is a different network, and the router is the device that's segmenting the networks, isn't it? All right. How many broadcast domains are there? So if you remember what I said about broadcasts are within each LAN. So how many broadcast domains are there in this diagram? 3. 3 networks, 3 broadcast domains. Correct. Okay, so it's just different words, but means the same thing. So just remember, a broadcast is within a LAN segment or a network. So now the next question is discuss and identify how communications occur between these segments. So if we're talking about this picture again, and let's say that admin PC here needs to talk to the factory floor PC, how would it get there? So just looking at this picture, how would this PC get to this PC if they want to talk? Through the switch and through the router, right? So a bit like what we talked about this morning, didn't we? We talked about how we got the default gateway. We talked about we got the encapsulation, and then we go through the router, and then it gets to the other network, right? That's the line of things you need to try to explain, okay? And then, so the next question is the principle of least privilege. If we read that, I'll just give you a rough summary. Principle of least privilege, it means that you only allow the minimum that's required for the people to do their jobs. Okay. So if I open too much, or let's say my house, if a person who's gonna fix up my garage roller door needs to come to my house and fix up the roller door and put an automatic roller door on there, I'm not going to give him access to my whole of my house, am I? I'm going to give him just enough access, which is the garage, so he can work on the roller door. Because if I know the guy is probably trustworthy and all that, and everything's good, but there's a chance that if I give him access to the whole house, we might steal something. He might go through my personal possessions if I'm not there, couldn't it? So it's the chance of something happening that we want to prevent by limiting the access. So in IT, if you guys as students need read and execute to a file, I will only give you read and execute to the file. I won't give you full control, because obviously if you had full control, and I'm sure all of you wouldn't do anything bad, but you could. Okay, so that's the principle of least privilege. Just give the people just enough privileges, just enough rights, or you allow things or access to things enough for them to be able to do their job. So if you remember this table was in the previous question as well. We identified the different protocols. But if we look at this, so first of all, so now if this question, review the following principle of least privilege, which is what I just explained. According to the principle of least privilege, where only the absolutely required for the function or requirements of the job is allowed, what protocols must be allowed to traverse through the TSA meets router? Sorry, I think I missed the question. Okay, no, I didn't. So obviously, if this is where traffic has to go through, this is where we can control traffic, isn't it? All right, so if it's just like a checkpoint on like a border gate. Like if people have to go through this border to go from, China to Vietnam, then in this border, I can control who is allowed to go through the border and who's not. And that's where we can set up what's called filtering rules. Okay, we'll learn more about ACLs or access control lists in the future. But this is where we can set up those rules. And you might already know that a little bit from your home router. You might already have some sort of firewall rules that you can configure, or you might have already done so. So if everything has to go through this router, this is where we can control whether this computer can go here, or this computer can go there, or this computer can go to internet, and what protocols are allowed. So the first question is, if we want to upload quality assurance photos, remember the scenario, where are we located? Where is the products being produced? Factory floor. That's the computer I'm using on the factory floor. And where does the photos need to be uploaded to? Sorry?
Admin office.
Admin office where? Though? It's not admin office PC, surely. It's not that PC. If you remember the scenario, which device or which thing do I have to upload the photos to?
Server.
Correct. The web server. So if this is the source, this is the destination, and And if I think so if we look at the protocols, we're not sure, but it's a DNS and web server, isn't it? So that should give us some clues about the protocol, shouldn't it? Okay, DNS is one protocol. Can you upload files with DNS? Guys, can you upload files with DNS? What did we say DNS was before in the first lesson? Domain name server. That allows us to resolve what's the fully qualified domain names to IP addresses. Does that sound like file uploads? No. Okay. But have you uploaded files to a web server? Yes. So if that should tell you, if you the description here, those are the protocols we're using. So therefore, what's the source? So in this communication where we're uploading the quality assurance photos, what is the source?
PCs.
Sorry? Which PC? Factory floor PC. Yes. What protocol? So we just looked at this description, right? What protocol? We said that DNS wasn't the protocol. What's the protocol? HTTP, HTTPS. Okay, so there's two types of web protocols, HTTP, HTTPS. The S stands for secure, right? That's probably more likely than not likely, okay? And where does it need to be uploaded to? Exactly, all right? So this is what we're gonna allow for the router, aren't we? We're gonna allow not anywhere, specifically that specific factory floor PC, using HTTP or HTTPS to the web server. Okay, so that is a very strict rule. That means I can't use that protocol for any other purposes except for that, from that computer to that computer. I can't use it to access I can't use HTTPS to access the admin office PC, can I? Because that rule is specific source, specific destination, specific protocol. You see how the principle of least privilege is obeyed there? Okay, so if you make it so strict that that's the only possible source and destination protocol, that means it's a lot more secure than if you just create a general rule. Okay, so are we following? We all good back there? Yeah, all good. So the next thing is OneDrive. Where's OneDrive? Oh, it's not on the PC. Correct. So where's that? Right here, isn't it? Yeah, it's in the internet here. Okay. So what you can do is the destination is just internet, and the source is already told you. Okay. And what protocol? Remember OneDrive. What protocol were we using? So here's OneDrive. Here's my files. Oops. What protocol am I using? All right. So if you remember, we spoke about this in the previous one, didn't we? So again, here from admin PC, factory floor PC, protocols HTTPS, where the internet. Okay. So you can I think if you put this together with the previous question where we identified the protocols back here. So it's the same sort of things except for the uploads, but we just spoke about the uploads anyway. You can finish off this table. All right. On which device can the traffic be managed, or by allowing or denying traffic? Router, correct. All right. And obviously, if you're answering, it's not just router, it's the specific name of that router. So it's router, TSA meets router. Okay. and here we haven't done this one, but we'll talk about it anyway. So this should be B actually. Well, why is this A? Which feature on the identified device can be used to create create the rules to allow the traffic identified in? No, that's right. A. So this is the traffic here. So what was that thing I called that we'll cover later on?
Lens.
It starts with A. It's an acronym. ACLs, if you remember. Okay, access control lists. And that's something we're going to cover in the future. So it's a little bit unfair, but I did mention it just before. So it's a bit of not so much I taught you, but we talked about it. Oh, this one's a little bit hard. Layer 2. So we're talking about segmentation again. So segmentation is dividing this network up, right? So the router, what layer device is that? Layer 3. So that's a layer 3 segmentation we're talking about here, right? Which device here is a layer 2 device? Switch. Ooh, okay. So therefore, what is layer 2 segmentation? So now, this is, huh? Yeah, what's layer 2 segmentation?
Not transport, no.
No.
It's just data link.
Data link is layer 2, but what is layer 2 segmentation? Frame is the addressing. Layer 2 segmentation. I think we spoke about this, VLANs, right? That's where if we have two physical switches, they're different physical networks, aren't they? Okay? If I've got a PC plugged into this switch and I've got another PC plugged into that, they're not connected. They're separate networks. But what if I don't have two physical switches? What if I have one physical switch with 24 ports, but I want 12 of these computers on one network and 12 of those computers on another network? I could actually do what's called VLAN, virtual LANs, and divide these ports to be one LAN and have those other ports on other LAN. That's segmentation, isn't it? We're physically separate. We're not physically because we're not cutting up the router in half, but we are effectively turning that router into two routers with the aid of VLANs.
Sorry, Alex, you mean if you have one switch with 24 ports,
yeah,
you can use that switch for two different networks?
Correct, with VLANs. That's what I just said. Okay, so what if you need, if you want two networks and you only have one switch, do you go buy another switch, or you just use the one switch and use VLAN feature? Okay, so that's what layer 2 segmentation is all about. Virtually distinct partition by using VLANs. Each VLAN forms its own logical layer 2 segment. All right, so layer 2 segmentation is VLANs. Do you think we need layer 2 segmentation? So if we use this VLAN to separate this network, do you think we need it? No, we don't, because we've got the router, right? What's another reason? If I had a layer 2 segmentation, let's say this server and this switch are on two different VLANs on this, sorry, this server and this PC are on two separate VLANs on this switch, can they talk to each other? Because they don't have a router in between, do they? That's right. So even if we just had layer 2 segmentation without the use of layer 3 router, you can't even talk to each other anyway. Okay. So hopefully you're on the right track. So identify whether could benefit from layer 2 segmentation. Keyword is instead. No, it means no layer 3 segmentation. Well, you can't. If you don't have layer 3, you don't have a router, the segments can't communicate with each other. You get me, guys? Yeah. All right, so I think, so the next part is fairly, if you remember, one of the things you had to look up was to find the switch. Okay, this is something you guys have to do. You have to make sure you look at the requirements of the thing, find the switch with all the requirements, and then you put in here the cost, etc., etc. And then you talk about these guidelines and security policy for treating these type of attacks. That's just going to this manual and having a look at how these things could be protected against. Check the availability. So this is something like what you have to do is just write an email. Don't send the email. Okay. Do not send the email. just paste a screenshot of that email. But what I'm looking for here is that you're able to communicate effectively, but your mannerism, like as in the way you wrote your email is professional, and it's addressed to me, and confirms some of the key specifications that's in your switch. Okay, the language like, can I confirm that this switch is capable of VLANs, or can I confirm this switch is capable of the Power over Ethernet, and stuff like that. And here's what, this is the email you'll get as a return. Just pretend that that's what you got. And this deployment plan is now you have a good idea of what you want to put in there, the devices, the internet connection, and the cabling and stuff like that. Think of some major tasks you have to do. Okay, are you going to just go walk in there one day and just start doing it? Or do you need a plan? Maybe I'm going to, decommission the current switch, but do I decommission it first, or do I install the new switch first? How much is it going to take? Which days do I need? If I had to do it in 3 weeks term, starting week 3 of this term, just use those dates and determine how much downtime there is. It's just like if I'm here to fix up your garage door, I'm going to tell you, I'm going to be there on Friday between 6 a.m. and 10 a.m. It will take me 3 hours. And during that time, you won't be able to use your driveway or your garage because I'll be working on those on your garage door. That's effectively the same thing. Yeah, the downtime. Like if my computers currently are connected to an existing network and all of a sudden I'm going to take that network offline, can they do their work? If they can't, then that's a downtime. Obviously, you want to minimize that if possible, but you got to at least tell your customers when they expect not to be able to use it so they can plan for it. Okay. All right. So that's a plan. And then we need to do a face-to-face meeting where you'll give me some overview of the task. Don't need to go too much detail. Overview of the devices you selected. Again, don't go into too much detail. And then you just need to get your customers to say, okay, go for it. Yeah, get approval to go ahead with this design. Okay. And during that, I'm looking for, communication skills, ability to communicate effectively, be able to clearly communicate with someone that may not be the same level of technical skills as you. So, so look at that. So we'll leave it there. So that's our installment of how to pass the assessment today. Okay, this is a very, very important slide, guys. Take a mental picture or write down a little note. This is a very important slide. This is what's called a freeway handshake. Okay, it's how a TCP connection is established. Before anything can be sent, any data is sent through TCP, it needs to establish this session. All right, step 1. Okay, let's look at this picture. Computer A wants to talk to computer B. So it needs to establish a session. So step 1 is SYN. It's basically sends a SYN packet. It basically means synchronize. I want to synchronize with you so we can talk to each other. So B gets the SYN message and it says, I acknowledge your synchronization. So I want to synchronize with you. No problems. So it sends a SYN-ACK or synchronization and acknowledgement. Then once this is acknowledged, then A goes, no problems. Let's talk. So this establishes the connection, and that ends the freeway handshake. So this is almost like me saying, hey Matt, can we talk? Perfect. Okay, let's talk now. All right. So this is me getting his attention, asking if we can talk. He's saying yes, we can talk, and I say, okay, no problems. Let's talk now. All right. Why is this slide important? Let's go back to our assignment 1. Part 2, question 3. Explain how the factory PC, that's here, the factory PC, establishes a connection to the web server. Okay, so establishes a connection. This is exactly talking about the three-way handshake. Okay, so that's why it's important not only to know it just because this is actually a source of we use this three-way handshake in a lot of ways. Okay, I'll give you a description of why this is important. In the old, everything I talk about is going to be old. You know why? Because if I'm talking about it, it's already been well documented. So have you ever heard of a SYN attack? Have you heard of a SYN attack before? It's a DDoS. Okay, heard of the term DDoS? What does DDoS stand for?
No, I would say.
Distributed denial of service, okay? Denial of service means it's stopping your server from responding or communicating with their legitimate clients. Let's just say, hey, Javon, let's say you have a shop. What kind of shop do you like? What kind of business do you want to open? What do you want to sell? Tuxedos, okay? Suits, men's suits, okay? You're going online shopping, you're going to sell men's suits to all these lovely people here. But I go to you and go, you give me $10,000, I'm going to take your site offline. So what do? You give me $10,000? No, you're not going to do that. Okay, so so let's say you don't do that, and I then have all these computers infected on the internet with my malware, and I use my control application on my computer to send a message to all these computers with my malware to go now SYN flood Javon's web server. So what's SYN flood? So it's all of you guys. You just pretend you're part of my bot army. You're all saying, hey, Javon, can we talk? If you all said that to him, he's going to go, yeah, that person wants to talk to me. That person wants to talk to me. And let's establish this this communication. So Javon goes, yeah, no worries. Yeah, I'm free to talk. And then we just say nothing back. So he's actually left waiting for you. Okay, it's like, hey, can we talk? But then I don't talk to you. You're going to be sort of trying to say, yeah, are you going to say something? Are you going to say something? But after a while, you're going to say, okay, he just lost connection, aren't you? But in that period before he decides that that person is not actually going to talk, he's going to be focusing his attention on those people who want to talk to him. That's connections, that's open. That's memory that he's allocated. That's processing power he's set aside. So all of that time, he's not able to deal with the legitimate clients who actually want to buy a tuxedo from his shop. So a SYN attack, so let's have a look at SYN flood, really, is where the attacker keeps on sending multiple SYN requests, synchronization requests, and Javon saying SYNAC, but then the guy just leaves him hanging. It's like going for a high five, and then he just lets you, hold up your arm and not actually give you a high five. You're not going to be able to high five anyone else while you're waiting for that dude to high five you, right? So these other legitimate people can't establish a connection because it's too busy handling all these bad connections. Okay, so that's a SYN flood, and that's how an attacker in the past, have taken advantage of this process and to actually create a denial of service attack. So you know how once this completes, it's an established session, isn't it? So if we actually look at our thing, you can see that these are established. Okay, so all of this are established, so that's when it's finished this process. That's fine. But in firewalls, this is important as well, because if, let's just say, my left-hand side, Marianne, V, and Adam are my internet. Okay, and these guys, Leo, Yufan, Devon, and Matt, you're my internal computers. All right. If I was the firewall between you two, and Javon wants to ask Marianne a question, should I let Javon go through and ask Marianne a question on, let's say, port 443? Do you think that I should be allowed? Yeah, I'm the firewall, but she's a web server for free, and your internal client. Do you think that should be allowed? Yeah, so that's normally allowed, isn't it? That's fine. So Joanne tries to communicate with Marianne, and according to my firewall rules, that's allowed. And then Marianne responds, doesn't she? Here's the website. Remember what we said? The reply is on the source port, isn't it? Okay, the source port 49152. Let's say that's Joanne's source port. So Marianne replies on the source port, and basically me as a firewall understands that this is a reply to Joanne's question, wasn't it? So should I let that back in so he can get the website? Yes, I should, shouldn't I? Let's stop right there. Let's just clear the slate. I'm still the firewall, you're still the internal computer, Marianne's still the web server there. Now, let's reset the clock, go back to right at the start. Now, Marianne tries to communicate with Joanne on port 49512. As a firewall, should I allow that? Why not?
Because you don't know what the information that's going to be passed across is.
But in my previous scenario, I just let it through, didn't I?
What's the enemy service?
That's right. Key point, guys. He initiated it. And then the reply was part of this established communication, wasn't it? So that's why, as a firewall, I need to be able to tell the state of the communication. This is what's called stateful inspection, where I allow communications that was initiated by internal client to external device, the reply to come back through. Otherwise, if there was no such thing as stateful inspection, all those things would be blocked anyway, and you wouldn't be able to get your web page. Okay? Whereas if you didn't initiate the communication, and Marianne on the internet uses the same port, same IP address as the reply in our previous example to try to get into our network, as a firewall, I need to be smart enough to say that that's not a part of an established state, so that's blocked. So that's what's called stateful inspection. Okay, so basically, you'll find that all firewalls does that as well. Usually, what an internal client has requested is allowed to come back in. But if the internal client never asks for it, they can't just communicate with the internal client because that's blocked, because it's not an established connection. Okay, so again, this TCP/IP connection establishment is very important for all these functionalities. So this three-way handshake, okay, this is what we call it, three-way handshake. 1, 2, 3. That's why it's called three-way handshake. Establishes the session. What about when we finish? When we finish talking, we hang up, don't we? There's also a four-way teardown. So now computer A and computer B are finished talking. Computer A says, I'm done. See you later. And computer B goes, I acknowledge, see you later. And then also sends a fin as well. I'm finished as well. And then A says, oh, okay, I acknowledge that you're finished too. So now we hang up. All right, so basically this finishes the session. And basically this is what happens when Jovan requests a website from Marianne. They establish the session first of all. Marianne replies with the website. Jovan gets the website and they're done. Now Jovan hangs up on Marianne. Marianne hangs up on Jovan in that transaction. So three-way handshake, the functions of the three-way handshake establishes that the destination device is present on the network. Okay, are you there? I want to synchronize with you. And then they reply, yeah, you're definitely there. It verifies the destination device is an active service and is accepting requests. Okay, if Joanne was accessing Marianne on port 80 because she's a web server, then she's there, listing on port 80. If she was not a web server and she was FTP server on the other hand, which is 21, then she would never actually acknowledge his synchronization on port 80. It informs the destination device that the source client intends to establish a communication session on the port number. After the communication is complete, the session is closed and the session is terminated and the connection end session mechanisms enables TCP reliability function. Okay. To better understand how web browser and web server interact, let's take this. Here's the web server. Here's the client. The client's going to enter this URL. The browser interprets the URL in three parts. The first part, HTTP, stands for the protocol. So by looking at that, I can see it's going to be port 80. Okay, that's the protocol. Works on port 80. So I'm going to go to this server and knock on the door on port 80. The next part is the domain name, or fully qualified domain name. And www.cisco.com is the fully qualified name, so it's like the full name of this computer. And then this last part, index.html, is actually the file name. So I'm reading this really. Go to this computer, knock on the door on port 80, and get this file. Okay. Step 2, the browser checks with a name server, so DNS. What is the IP address for that? The client initiates then after it gets the IP address, the client initiates a HTTP GET request. So that's the GET command inside the HTTP request for this file to that server. Step 3, the request, in response to the request, the server sends the HTML code for the web page. You can see that's all markup language in there. It's got these tags with the pointy brackets, and that's going to send it back, and then the client displays the web page into the browser as it is meant to be displayed. That's what happens. Step 1, 2, 3, 4. Okay, let's take a second there. Where is it? Question 4. Explain how factory floor requests an intranet page and how the web server responds. Okay, so what do we just talk about? Pretty much exactly that, except that it's a different website, but same operations, isn't it? So I don't think you need to be a genius to maybe think that the last couple of slides relates to that question. Okay, so that's what I said, next lesson. So that's where we cover it, okay? So with the HTTP, there's more than just a GET command. So when you use put a URL in, you press enter, that's doing a GET command. Okay, GET means to download the resource, the page to your computer. We can also do POST. POST uploads files to the web server, such as data in a form. We can also use the PUT, which uploads resources such as contents to a web server, such as an image. And we can, depending on which one of those commands that's embedded in your HTTP request, we will do it. HTTP is not secure. So if we just use purely HTTP, then we could, someone on the internet could potentially just sit there with Wireshark and capture all your packets and read your data, okay? Because it's not encrypted. Whereas HTTPS is encrypted. And so they can still sit there and intercept all your packets, but when they put it together, they can't recognize it because it's all been scrambled up.